The following is my conversation with David, who is one of the four university students who won the third prize of AIMO, Artificial Intelligence Math Olympiad. The reason I'm talking to David is out of the top three solutions, David's solution is the only one without any kind of fine tuning. I was so shocked when I read the simplicity of the solution. I wanted to bring David's perspective for all of us to learn and understand how this solution won the third prize of AIMO. And here is David. Hey David, welcome to the One Little Coder podcast. Can you please introduce yourself?
Oh, yeah, thank you for having me, first of all. My name is David. Me and my three other members of my team participated in the Math Olympiad contest, and we got third place, which was it was one of the most fun competitions we took part in, especially because it tackles one of the most complex and important problems with LLMs currently.
Okay, and what do you do other than the competition outside of it?
Yeah, so we are four of us. We are just finished our bachelor, and we all just went to masters now. Just we were just undergraduate students. We
Hmm.
actually participated in this during our thesis, which was a bit hard to keep in time with both of the two things. Yeah,
And what do you study? Like math, computer science, what is it?
computer science, all of us.
Computer science. So generally, are you interested in like anything that happens in the AI world, or how is your interest towards computer science?
Yes, we are all very interested in AI, and we would like to do research in it.
And all of your team members, I think the four team members, all of you are from the same university, same class, or how did you form the
Yeah,
team?
same university, same class.
Okay. And for people who do not know anything about AIMO or AI Math Olympiad, can you just give us a little bit of brief introduction?
Yeah, sure. So I believe it was started and is funded by XTX Markets. And basically, the scope of the project would be to get an open source AI assistant which performs at the level of a gold medalist in Math Olympiad.
Okay. And I remember like they had certain conditions about how would they evaluate the price. I think the first one was like the earliest solution with I guess like the Abdur Rafi's solution won the prize. But for the main track as well, there were like a lot of conditions, right? Like tool usage and all the other things. Can you describe about like how the price or conditions of the competition went?
Well, restrictions, you mean? Okay,
Yeah.
yeah, so it had to run on Kaggle on their hardware in under 9 hours, which
Mm.
sounds like a lot, but it's not actually a lot. We got like 50 problems to solve. Technically, or to unlock the big prize, we would have to get 47 out of 50,
Mm.
which is actually very hard. The winning solution got 29 out of 50. And
And
besides the time, also the hardware on Kaggle was a real challenge, as they don't have the newest GPUs, and you can't benefit from any of the developments like the hardware. Like, I mean, even flash attention, you don't have flash attention. BF16 is not supported, so
yeah. And
yeah.
tell us, like, how did you start with, like, let's say the problem is there, the competition starts, maybe like before Abdur Rafi's solution or after that, like, how was the journey of, where?
Um, well, all started. I think like the community started by searching for the best open source LLM for math. Initial solutions use the low models like Mistral. Many people tried to fit like Mistral 8.7b inside. It kind of worked, but it didn't perform too well. Everything changed though when somebody decided to use the DeepSeek Math 7b RL model, which was a huge improvement in score. And at least from then on, everybody used that model.
Hmm.
Besides the winning solution, which used the base model to fine tune it further.
Okay. And w- was it like always like an LLM based approach that was in the play, or there was another approach that you guys tried?
It was always an LLM based approach, though at some point with um, Abdul Rafai's notebook, we also decided to execute the code the LLM generated, which was interesting because before we didn't execute it. When it did, that also unlocked quite a huge boost in score.
And how did you get this idea about you wanted to execute the output of LLM and then use that?
Not really my idea. though I would say it comes natural because you will want to give it feedback of the code that it generated, and then you should base it on something real, so like the actual code.
Could you like give us a presentation or detail about more detail about your solution?
All right. So yeah, I talked about the task. Uh, just to reiterate, 50 problems for the public leaderboard and 50 for the private. We only had 10 problems for trading. And all solutions, this is very important, had a numerical answer between 0 and 9999. So if you, the problem could have an answer bigger, but you would do modulo on that. But most importantly, we don't evaluate proofs, just numbers at the end. Our solution was heavily inspired by Abdul Rafai's notebook, which was the early progress prize winner. So we used an LM as a backbone that was pre-trained on math and fine-tuned on math. Furthermore, we used the already established paradigm of chain of thought reasoning, which has been shown to improve the quality of answers given by the LLM. We then do chain of thought generation with tool integrated reasoning. Basically, we allow the model to execute code in a Python repo and get the output back and iterate until it's ready to give the final output. We apply self-consistency on as many candidate solutions as we can. Our aim was to, one of the things we did was to try to make as many generations as possible. And then after that, we apply basically majority voting with the custom solution score we developed, and also some small tricks we found that really improved the score. Yeah, so two observations we found that, of course, we aim to maximize the number of solutions, candidate generations we make on the LLM. We did this to improve stability and slightly the accuracy. Stability was a huge concern during this competition because some solutions got anywhere from like 17 score to 22 score, so that's a huge range. As you can see, this plots, but when the number of generations goes up, also the stability is better and the accuracy. We also found that somehow, I mean, surprisingly for us at least, the precision kind of mattered. So we decided to go with FP16 for our model, but technically the BF16 model would have been the best, and it gave at least more validation set the best score, but it was too slow on K. The winning solution actually used 8-bit, which was also an option, but they fine-tuned it. So at least for DeepSeek RL, this is not a good option. So when it comes to the model, we use the DeepSeek Math RL model with no extra fine-tuning. All of our attempts to fine-tune were unsuccessful. And end of the community, besides two exceptions. Yeah, we kept the model in FP16, and the RL version showed the best score, significantly on the math dataset.
Just a question. When you said it was unsuccessful, were you not getting good result, or the fine tuning configuration it itself did not work?
Yeah, so we were just not getting good results. We are not exactly sure of this, though one possibility is because we fine-tuned the already fine-tuned RL model, and yeah, that might have made it lose a lot of information.
Makes sense. Thank you.
So in order to generate the candidate solutions, first of all, you use DLLM due to the excellent performance it gave when compared to alternatives. We also decided to parallelize the execution of the code the LLM generates, which also proved to give a significant boost in a number of candidate solutions we had time for. We start our generation with one of the two prompts we adapted. The chain of thought prompt encourages thinking about the problem and mentions using programs only a tiny bit, while the code prompt heavily endorses the use of Python and SymPy especially to get to the solution. We split the total number of generations we can make between these two prompts into like a 3/7 split and 4/7 split between them. Now I'll show the flow of actually generating a candidate solution. We start with any of the two prompts we talked about. We query the LLM to generate a response, and we stop right after it finished generating a code block. In this example, we asked for the square root of 4, and the LLM gave us a simple Python code that will do the calculation. We then extract the code it generated, execute it, and concatenate it back to the generation, the result. One such generation execution loop is what we call an iteration. We allow our model to have a maximum of 7 iterations for each candidate solution, during which the LLM can fix any errors in the code or just work out the solution step by step using code. After filling the output of the code execution back, we query the LLM again in order to get the final answer. We then extract the final answer from the box format here. As you can see, the answer 2 is in the box construct here. The LLM, unfortunately, often would forget to actually use this format, even if specified in the prompt. Instead, it will just say the answer directly, like in this case, without any box output. He said the answer is 2. In order to help with this problem, we try to force the model to output the answer in the format we want. And we do this simply by concatenating one more block. We do this if the model did not give any code, but also did not give a final answer. The block contains a string that says the final answer is box and ends in a cliffhanger, and we just complete it with a few more tokens. This method works surprisingly well and gives us a lot more successful outputs without relying on other more complex or error-prone extraction methods that were used in this competition. Another alternative the community used was to just get the final number from the text, which of course has many problems.
Can I ask one more question?
Yeah.
The prompt example that you gave was in the competition. Did you prompt exactly like this? For example, the question was there, and did you just say answer using chain of thought with tool integrated reasoning, or were there like a few short examples that would explain how to do chain of thought?
So the sorry, yeah. So the two prompts were exactly these, without any few shouted examples, because we found that it didn't work and it actually confused the model quite a bit. So the model we just answered from like one of the examples before. There was also a lot of people that tried drag, but that didn't also work. So yeah,
So yours was basically like a zero shot chain of thought. You're trying to induce tool reasoning and then extracted the code and then ran it.
yes. Though we iterate on it multiple times
And
until
you
it gets
create
to the
like
final.
candidates and then do majority voting, take the final solution.
Yeah,
That's great.
pretty
Okay.
simple. Just something about, because we of course do not generate just one candidate solution, but a lot of them. We go one iteration at a time, and we use VLM to generate all candidate generations in. After all generations are done for iteration, we execute the code in batches. We then continue like this until either all generations finished with an output, or we exceed the maximum number of iterations. Our goal was to be able to generate around 50 to 17 generations for both of the two prompts we used, so like 114 total. We managed to get to around 140 generations on average. We found that by running the code in batches, we managed to squeeze just enough performance to hit our goal. And especially, we believe that the number of generations we made, even if at least from the benchmarks from the test we saw, kind of plateaued at like 50. We think this allowed us to keep our stability, because one thing we did from other teams was that on the public we were like ranked third roughly, and on the private we also ranked third. But many other teams that were like close to our score went down. Yeah, so I think this helped, even if it didn't seem like it would at the start. Yeah, so after generating all solutions, we need to score them. Our scoring is based both on the final result, but also on the code outputs that led to it. we only give a tiny amount of points for just getting the final answer, namely like 0.05 only. Text answer, we mean just the final answer at the end. We instead give the most points if the final text answer agrees to the code outputs. By agrees, we mean that the final answer is like contained in the code execution output at some point. So if like the LLM made a code that generates the final answer, then we consider that valid.
Hmm. And
Because
just for my understanding, if the example that you showed, the final answer was 2,
yes,
and for that you are giving like plus 0.05.
for the final thing, yes, but then we give 0.8 because the text would be contained in the code
Hmm.
output when you said like the final, yeah,
Okay.
if.
And what was the reasoning behind these two levels of scoring?
Um, so we basically want to give, I mean, the LLM would often like make errors in the code.
Hmm.
It would get an answer which was wrong, and then just hallucinate the final answer anyway. Especially with our forced formatting thing,
Hmm.
we would just force an answer. So we just wanted to see that, okay, if the answer makes sense, it should have been at some point in some of the code execution, at some partial result or final result.
Hmm.
Another option would be just to consider both of them as the points for the candidate majority voting, which was also used in the competition. Um, I mean, both ways work pretty well. We had actually another submission which did that instead, but it just got a bit worse than our final.
Hmm.
So, yeah, both are.
And there was no scoring before the code execution. Every scoring starts only after code execution.
Uh, yes, after I mean after the full generations is done, then
So,
for the scoring.
okay, what I mean is, the first stage would the LLM would give you the answer with the code. At that point, you're not minding whether it is a good answer or not. All you are looking at is like after that code is executed and the final answer is calculated. That's where you're doing the scoring part.
Yes.
Okay.
Yeah. One important thing is that if you do not consider the code answer at all, like not even for majority voting or for this alternative, you get significantly worse scores. So
Hmm.
it matters quite a lot.
Okay.
We also do some penalties. Uh, Interestingly, the LLM made a number of very predictable mistakes. So we saw that at least in our validation, we saw a lot of errors with small numbers. So just the LLM with at the end, I'll put a very like a small number between like 1 and 10 as a wrong answer. Also, relatively often the actual error, I mean the final answer, will be contained in the problem formulation, which sounds very weird, but we believe this is because we forced the LLM to output a number. If there is no number that it could find, it just goes from the prompt, basically.
Hmm.
Like, yeah. So we penalize this type of solutions as a percentage of the number of solutions started from the problem. We do -5 for the total generations for small numbers and -10 for problems that are part of the numbers that are part of the problem. Even if these seem like tricks, they actually boosted performance quite a bit. On validation, we went from 23 to 25 to 27 with both penalties. The performance was less drastic on the leaderboard, but still significant, like 1 to 2 problems. It's still quite a bit of a hack. One with maybe try to use a reward model that is good and weight the solutions this way.
Hmm. But
Yeah.
using a reward model would take the solution to run much longer than what your solution ran, right?
Yes. Yeah, that was one problem.
Hmm.
Of course. I think the second place winners did use a reward model
Hmm.
successfully, but I think they did very well on the private leaderboard, though I'm not sure of their rank on the public. I think it was quite worse. So it's not
Hmm.
as stable, I guess, because
And
you generate less solution.
and you just like mentioned about your validation where you had the validation data and you looked at how stable the score is. Can you tell us a little bit more about like how did you build that validation data set? Like, did you keep bunch of questions separately, or what was it?
So we used just 48 problems from, I think, AIME 1983 to 1986. Just
Hmm.
some problems from there. It was strictly in the community that was very interesting problems to keep in the validation. We would, I mean, it would be a good thing if we would have extended the validation to more problems. As even in like 50 problems, like 48 problems, we still saw like a 2 to 3 variance in our score, which is very significant in this competition and made scoring quite hard because you need to run the model multiple times to get like a mean
Hmm.
at
So
least.
you used all the 50 problems that were part of the training data set, and you built a separate validation data set from the historic questions, and then you kept that as a validation data set.
We suddenly had only 10 problems from the train data
Oh, sorry. Yeah,
from the
I'm sorry. Yeah, my bad. So
competition.
okay.
We only used the validation because also the train data that we were given was not really representative of the actual leaderboard because they were a bit harder. They even mentioned it was like on the harder end of problems. So like even our model like made on average like 3 out of 10 problems from that train data set.
Makes
But
sense.
yeah,
And when you were trying to, let's say, get the right prompt and all those things, did you do like any kind of data augmentation, like get more questions other than the 10 and then try to see how it responds, or it was just the 10 always?
just the 10. Yeah, for the
Just
train.
okay, nice.
Um, yeah, we sure how it is. Okay. So we also tried some other things. Um, we mentioned that VLLM, especially on the T4 GPUs, does not actually support BF16, not even emulation on the of BF16. So we tried to actually make a fork of VLLM that allowed for this emulation, just basic downcasting and upcasting for the attention kernel. But sadly, I mean, this gave us the best score on a validation dataset, but was not very stable on leaderboards or even select estimation. Uh, Another version of our notebook involved doing the whole candidate generation that I talked about in one single VLLM call by manipulating the model logics to output the correct code outputs instead of like stopping the generation and concatenating the outputs back. This version allowed us to exit quite quickly on simple problems and brute force as many as 300 generations on hard ones.
Mhm.
Uh, Unfortunately, we didn't select this one either because um, we believe that there would be many ties in the final leaderboard, so the actual submission time mattered. So,
Mm.
but yeah, this is something we'll look at in the next competition.
So would you say that had you had like more runtime than 9 hours, would you have had like a better number of predictions than I think yours is 27, right? The final on private leaderboard number of
On
predictions.
private leaderboard, it's 21
21. Okay.
problems out of 50.
And the first prize is like 27?
29, I think.
29. Okay.
Yeah, it's a big
So,
difference.
okay. So, would it have helped you more than 9 hours? Or,
Yes, but I don't believe for our current solution.
mhm,
We Other things we could have tried would be like three or fours. There were some attempts, but I don't believe anybody made it. I mean, there is a version for the first winners. So I'm not exactly sure if it's the full three or fours thing. And also using like a reward model would have been made like this year.
mm.
Because yeah,
And, and what was the reason that you guys settled with the 7 candidates? Is it like the runtime or anything else?
the 7 iterations
Yeah,
or no.
candidate
So
generation.
for candidate generations, we do like 140 of like 7 depth, basically.
Oh, okay.
That's what I
My
mean.
bad. I thought like only seven candidates. So it's 140 candidates and seven
Yeah.
iterations.
I mean, yeah, for the generations, and like the depth would be 7, like here, 7 maximum.
Okay, makes
And
sense.
we, yeah, 104. 7 iterations was already quite a lot.
Yeah.
So we chose like the most we could.
Okay.
Yeah, and 140 is already also a bit overkill. But
Mhm. And when I read all the solutions, one thing that I felt is like yours is probably the simplest solution. I mean, I mention it in a very positive way. Like usually, I've been following Kaggle for so many years, and I know for even point zero 0.05 or a point zero 0.0555 improvement, people do a lot of weird tricks on Kaggle because Kaggle is such a platform. But yours is like a very simple, plain solution. Like, what is the motivation? Did it like work? That's why you guys like stuck with that, or was there like any approach to go very simple, understandable solution? What was it?
so I mean, our performance actually came as a shock because we just started the competition. Our initial thing was looking at the current notebooks. Uh, we basically saw the notebook that was the most popular at the time, the Abdul Rafai's notebook. I mean, joined before, but when we saw that, we decided to pivot our solution, and we just decided to use VLLM because we realized that we actually need a lot more candidate generations. I think the initial notebook generated like around 20, I believe, or even less. So yeah, and then we tried a lot of things, way more complex things that didn't work out at all, and
Mm.
nothing improved our initial score, which was quite shocking.
And when you say complex thing, it is like the VLLM fork, or in the model itself, you tried like different things.
We tried the fork that didn't quite work out. We also tried doing a lot of fine tuning. Like we spent a lot of
Mhm.
time actually trying to find in the model. Maybe if we would have collected some quality data sets, would have worked. But yeah. Also, we tried using the real models quite a lot, which surprisingly didn't work out for us. Maybe it did because that's what I was saying. Because the second place winners were also using the war models. They didn't do well on the public, but on the private they did very well. So
Mm.
maybe we actually would have got some improvement with the war models, but we didn't. Yeah, so that's
But
why the solution is simple. We just didn't manage to do it better. Hmm.
and during the course of the competition, did your ranking fluctuate a lot, or you because you mentioned that you had like a pretty stable number of outputs and score?
So I think this was like in the middle of the competition. We got to first place, and we stayed there for like a month.
How?
And until the end of the competition, there were 2 teams, so like Numina, which is the current first place winner, and another team from, I think they made the meta map, if I remember
Mm.
correctly.
Mm.
They said they got disqualified, which was
Oh.
a sad encounter. I'm not, there were some problems there, but
Mm.
yeah, and we then stayed at third place until the end.
Okay. And how happy are you with the third place? Like, were you expecting more than this, or are you happy with this?
I mean, I'm very happy with it. Yeah.
And are you guys like planning to take this forward into some kind of a research, or what is the next step with this competition, or is it like done? You want to venture into new areas?
Well, there is the second edition of this competition coming up soon. I think the organizers mentioned like actually September.
Okay.
So we are definitely going to participate and actually try some more complex ideas, especially because we can now actually fund our experiments.
Everybody in your team has the same set of skill set, or like how did you guys like build this skill set? It's just generally like you said, going through the other solutions, figuring out what you have to do, or you came with a very niche skill set.
I don't think I just had some previous experience with LLMs and I did some fine tuning and some RL things, but most of us didn't have a lot of experience, especially
Mm,
as undergrads. So I think we most of us learned on during the competition.
mm. And
No, yes, experience.
any tips for anybody who's like going to start the second edition of this competition?
Uh, well, I would for sure look at the newly released model from Quantum
Mm.
Math, which does very, very well on the train data sets. I just tested it out.
And surprisingly,
Yeah.
both are Chinese models. The DeepSeek math is also Chinese model, and Quen is also Chinese model.
Yeah, it's actually surprising how dominant the DeepSeek Math model was during the competition. Like nothing else worked.
Okay.
Yeah, and now Quen seems way better than all of them.
Mm. Mm. And you also mentioned that you wanted to go in the research side, like after your masters, and mm, anything about it. Like, is there any interesting area? Like, are you looking forward to spend time on?
Well, currently I'm really interested in the LLM area of research. Though I still have quite some time to think about it, and especially with how fast moving the space is. Yeah, I'm not quite sure. Maybe
Oh,
LLMs become obsolete, and we use only models, and maybe we get AGI. I'm not sure.
yeah, we might have strawberries. Who knows? Yeah.
Yeah, yeah,
Um,
strawberry.
yeah. And are you like a celebrity in your university now after you won this thing, or like how is it like after winning this?
I wouldn't say a celebrity. Just my friends were like shocked.
Nice, nice. Anything else that you would like to add, generally in terms of this competition or generally LLM research, anything?
um, I mean, I would just say like any undergrads that want to start, I think it's a great place to start. It's,
Specifically
especially the
Kaggle or
competition.
LLM? Are you talking about Kaggle or generally LLMs?
LLMs, but also like the Kaggle competition is very fun, and you like learn during the competition. I think it's a very good place to learn.
And
Yeah.
one final question: are you participating in ARC ARC prize competition?
Uh, I'm thinking about it, though I'm waiting for my cluster to hold the money, and then I will. We actually
Hmm.
have quite some ideas there,
Okay.
but yeah,
Um,
we'll see how
so
those pan out.
that's a lot of prize money. So anything is good. So, I mean, for ARC, I think the prize money is like $1 million or something like that.
Uh, yeah, though I think it's if you actually beat Arc fully, right? Because I think that's impossible.
Yeah, yeah. And that is a
Or
question a
like,
lot of people ask, right? Like, if you have a solution that can beat ARC, are you going to just take the 1 million prize money, or you're going to start a company and then raise venture fund? Yeah, that's a different thing.
yeah, I mean, I don't, at least how the Kaggle is progressing, I'm not too, I mean, I don't think the big prize money will be won this competition at least. I
Okay.
think it's stuck on 43% for quite some time.
I think, yeah, right now, I remember like around 40-ish percent. And I tried to solve ARC manually. I could not solve. Um, I was like, okay, maybe my IQ is so low, LLMs can solve this. I cannot solve this. I stopped. Yeah. Yeah.
Yeah.
Thank you so much for your time, and I learned a lot from the solution. I wanted a lot more people to know the solution, and for me, like I said, I went through a lot of solutions, and this was a solution I personally felt very interesting because, like I said, right, Kaggle is a place where people try a lot of shenanigans to improve the smallest accuracy. If you see any NLP contest, people would try weird embeddings, train their own embeddings, a lot of data augmentation. But your solution was like, the moment I read it, I was like, oh, this is so amazing, so simple. And this is a third prize solution. I was like quite fascinated. So I was waiting to talk to you for quite a while. So thank you so much for your time.
Thank you for having me again.
Thanks very much.